We're going to solve quadratic equations by factoring, but technically this works for all polynomials, and we'll even do an example one where the degree is higher than 2 to show that this still works. Factoring is going to be our next easiest way to solve a quadratic equation, but to use this we need a theorem, an idea. And here's what it says. This goes by a bunch of different names. I really don't care that you know what the name of this is. But it says if you have A times B equaling 0, then A is equal to 0 and or B is equal to 0. Now this goes by a couple different names. Sometimes it's called the zero factor property or the zero product principle or a whole bunch of names. Don't care that you know the name, but you do need to understand the concept. Here's what it says. This is all it says. It says if you multiply stuff together and the answer is 0, one of those things had to be a 0, right? Think about it. Can you multiply any two numbers together and get an answer of 0 without that number being a 0? No, right? One of them has to be a 0 to get a 0 as a result. That's kind of special for 0, right? It doesn't work for any other number like 6. If I multiply two numbers together and the answer is 6, does that mean one of those numbers had to be a 6? No, not necessarily, right? So 0 is special in this case, and this is what we're going to use to help us solve by factoring. So let's go ahead and get ourselves some steps over here. Step 1, clear any grouping symbols. Step 2, move everything to one side. Step 3, factor. Now, as far as what our steps are doing here, so you can kind of get the idea, our first 3 steps over there to get us into a situation like this: clear all grouping symbols, move everything to one side, which means we have a 0 on the other side, and then factor. Remember, factoring is making things joined by multiplication. So the first 3 steps are to get us to this case up here. Now, once we're in here, we can use this idea that one of those factors has to be equal to 0. So we can use that to help us solve. We're going to take a more complicated equation and break it into smaller, simpler equations. So we're going to set each factor equal to 0 and solve. Okay, again, here our directions are still just solve. All right, so let's just try a few of these. Let's say if we have something like, all right, so if we were to classify this, is what you always want to do first, is say, well, this is a polynomial equation. Since the highest power is 2, this is technically a quadratic equation. So the first thing we want to try is extracting the root. However, we have something square, but not everything else is numbers, so we can't extract the root. So maybe factoring is going to work. So following our factoring steps, step 1 says clear grouping symbols. That's done. Move everything to one side. Now, technically it doesn't matter which side you move everything to, but since we generally learn how to factor with the lead coefficient being positive, you generally want to move everything to the side that keeps the lead coefficient positive. Just make your life a little bit easier. Now we can factor. Now you're going to go through all your steps for factoring. I'm just going to kind of jump to this rather quick for time's sake. 2 things that multiply to give me a -6 but add up to be +1 would be 3 and -2. So there's our first 3 steps. And now notice we have things multiplied together equaling 0, which is our case right here, which means one of those 2 factors has to be equal to 0. So either x plus 3 has to be a 0 or x minus 2 has to be equal to 0. Notice we took one equation, one complicated equation, and broke it into 2 easier equations to solve, and I'm going to solve these really quick. And we get x is equal to -3 and x is equal to +2. So here we have 2 solutions to this, which you'll notice for all your quadratic equations, you should get 2 solutions. All right, let's try another one here. Let's do the one we just did a second ago. What if we have x squared minus 9 is equal to 0? Now, if we were going through our steps for this, we would classify this as a polynomial equation. More specifically, it's a quadratic because the highest power is 2. The first thing we want to do is extract the root, which we can do. We saw we could extract the root, but here I'm going to show you that now that we have more techniques, you have more options. Now this, we can actually try to factor. So we clear our grouping symbols, which is done. Everything's already moved to one side, and this will factor, right? That's the difference of squares. Now that it's factored, here we have two things multiplied together equaling 0. One of those factors has to be a 0. So we get x minus 3 is equal to 0. Again, solving really quick, we get our two answers. Now notice that was nice, quick, and easy also. So see, factoring is the next quickest way to solve these. All right, going back this way just to give us a little bit more room. Let's say that we have okay, we're told to solve this, and like always, the very first thing we want to do is classify this. Well, it's a polynomial equation because all the powers are whole numbers. But what is the highest power? Again, you got to kind of look into the future. Now, step one says clear grouping symbols. So imagine if I were to clear grouping symbols, what would the highest power be? Well, if you think about it, if you start distributing, you'd have an x squared, an x, another x, and a number. So the highest power is x squared. So this is quadratic. Now, notice we can't extract the root because we don't have anything just sitting there squared. So that doesn't work. So maybe factoring. If we start following our steps for factoring, we clear grouping symbols, move everything to one side, and factor. Now remember, those first three steps are to get us to where we have things multiplied together equaling 0. But notice what we start out with here. We start out with things multiplied together equaling 0. So they're back over here to our steps. I'm going to put a star next to step 1. If you start with things multiplied together equaling 0, skip to step 4. So, if you already start out with, spelled equaling wrong over there, I think. If you start out with things multiplied together equaling 0, then all you got to do is just set each factor equal to 0. So here we have something like x plus 3 is equal to 0, 2x minus 1 is equal to 0. That one's really easy to solve. We get x is negative 3. Let's see, let's do a little work over here. So we have 2x is equal to 1. So we have x is equal to 1/2. All right, nice, quick, and easy. So this is kind of the best case scenario that you're going to run into. All right, let's still go through here and take a look at some more. Let's say we have something like, I don't know, x minus 2, x plus 3 is equal to 6. All right, again, we have to classify this. We're kind of looking at this and you say, if I were to multiply this out, it would be a polynomial equation, and of course it would be a quadratic because the highest power would be 2. We can't extract the root because we don't have anything squared, so we want to factor this. So step 1 says clear grouping symbols. Now, did we start out with things multiplied together equaling 0? No, they're equaling 6. Now, one of the most common mistakes, don't write this down, is students do something like this. Well, that would only work if when you multiply two things together and the answer is 6, that one of those had to be a 6, and we've already seen that that's not true. So that doesn't work. So we do have to go through all of our steps. Step 1 says clear grouping symbols. So let's start distributing. So I have x squared plus 3x minus 2x minus 6 is equal to 6. Next step says move everything to one side. But remember, our basic rule, before we move stuff around to an equation, we always want to combine any like terms that we can. Plus x minus 6 is equal to 6. Then move everything to one side. Again, I'm going to move it to the side that keeps our lead coefficient positive. And then I'm going to try to factor. Now this will actually factor. Again, for time's sake, I'm just going to jump through and do this really quick. Now we can use that zero factor property principle thing, right? We have things multiplied together equaling 0. It means one of these factors has to be equal to 0. All right, both of these nice and easy to solve. Just move the number to the other side. And there's the two answers that we were expecting. All right, so as you see, this works out fairly nice, fairly easy with factoring. The problem is not everything factors. We're going to take a look at one more example, and then the next video, we're going to take a look at what happens when things don't factor. So let's do one more here. What if I said, let's do x cubed Let's do plus x squared minus 12x is equal to 0. Kind of almost the same one we just did. Actually, let's change this. Let's make that a 20, so it's a little different. All right, so this is a polynomial equation. Now notice this is not a quadratic, right? The highest power is not 2, it's actually 3. So technically this is called a cubic. But we still want to try to factor a polynomial equation. Remember, that's kind of our topic here. So polynomial equation, you do want to follow these steps. So let's see, clear grouping symbols, I don't have any. Move everything to one side, that's done. And then we want to factor. So first step in factoring was greatest common factor. They all have an x, so I can factor out an x. I'm left x squared plus x minus 20 is equal to 0. All right, inside the parentheses, that'll factor some more. We can kind of do that shortcut inside there again. That's going to be x plus 5, x minus 4. All right, so here's where the idea that we, our zero factor property thing, whatever you want to call it, just gets extended. Here we have 3 things multiplied together equaling 0. Still, one of those factors has to be equal to 0. So either x has to be 0, x plus 5 is 0, or x minus 4 has to be equal to 0. Now here we have 3 smaller equations to solve. There's one's already solved. If we solve this one, we get x is negative 5. And over here, if we solve that, we get x is equal to 4. Now notice this time we have 3 solutions. That's because our highest power is 3. A little bit later on down the line, we'll see that when we're solving polynomial equations, we should always expect the same number of solutions as the degree of the polynomial. All right, so our first 2 methods for solving quadratic equations and or polynomial equations would be extracting the root, and then if you are solving a polynomial equation, you want to try to factor.